Good morning, friends. In last lecture, we discussed about the phenomena of total internal reflection. In the beginning of this total internal reflection, we just also discussed that this phenomena is most important because we had to learn about its uses. Some occurrences take place in our daily life that is due to the total internal reflection. One is that in this season, that means the summer season, on the road, we feel that the water is present, but actually there is not a water. Due to the phenomena of total internal reflection, we feel that at far distance on the road, here the water is present, and this effect is known as the mirage effect. We also learn about this effect in the uses of total internal reflection. First use of the total internal reflection is in diamond. We know that diamond is sparkling, and if the less intense light is enter in the diamond, so diamond is shown the sparkling. That means the brilliance, spectacular brilliance of a diamond is obtained. Therefore, the diamond are known for their spectacular brilliance, and this brilliance is depends on or due to the total internal reflection of the light. Here, when the diamonds are prepared, at that time, here the cutting of the diamond is done in such a way that the critical angle is very small. Therefore, the light entering the diamond at any angle always undergoes total internal reflection, and due to the reason, diamonds are shown the brilliance. Now, the critical angle for the diamond A interface is 24.4 degree. That is the value of the critical angle for diamond used in a medium. So that is very small, only 24 degree. Therefore, once the light enters in a diamond, it always undergoes for the total internal reflection. Therefore, multi-internal reflection takes place in the diamond. Therefore, we show that in less intense light, the diamond are shown the sparkling or the brilliance. Now, for total internal reflection, already we derived this equation, sin IC is equal to 1 upon n. Therefore, n is equal to 1 upon sin IC. IC is a critical angle, n is the effective index of the medium. Here the diamond A interface. Okay. Now, what should be the effective index of material of a diamond? Therefore, n is equal to 1 upon sin IC. Therefore, 1 upon sin 24.4 degree. Now, we require the value of sin 24.4 degree. Now, in log table in natural sin 24.4 degree. First, we have to convert corresponding to the 0.4 degree. What should be the minute? There is the 15 minute. Therefore, 20 degree and 15 minute we have to see in natural sine log table. So its value is 0.4131. 0.4131. And we subtract the value, so we obtain the effective index of material of a diamond is 2.43. Thus, using the concept of the total internal reflection, we can find out the effective index of material of a diamond. So in short, the use of the total internal reflection takes place in a diamond, and due to that reason, the diamond is shown the spectacular brilliance. Clear this? Okay. Now we are going to start a discussion about the second phenomena. Second phenomena is the mirage effect. In summer season, we know that the temperature is very high. That means there is a hot day, and very large amount of heat is delivered by the sun. Now in summer, due to the heat, whatever the air in contact with the ground, so what's happened? This air becomes the hot, and due to the hot of this ray, this air, it becomes the thin. That means that it becomes the red. While just about this hot air, that is the cool air, and cool air is quite denser compared to the hot air. So in short, in summer, due to the heat, the air in contact with the ground becomes the hot, while above it is cold. Thus, the whatever the air in contact with the ground is rare medium, is act as a rare medium, and just above this, that means there is the ground. Whatever the air in contact with this ground is hot and less denser, that means the rare medium. While just above this, the air is cold and also there is the denser medium. Right? Here there is no direct interface between the rare and denser medium, but yes, it's going up from the ground, so air becomes the more and more denser, more and more denser. Okay. Now, therefore, the effective index of the air is increases as we move upwards from the ground. So as we move upward from the ground, the effective index of air medium N is continuously increases. Therefore, the medium above the ground is having the continuously changing the effective index. Okay. Now, here we consider the one ray coming from the far top of a far tree, that means from the deep one. So this ray going towards the ground, that means it continuously traveling from denser to the rare medium, denser to the rare medium. Okay, in phenomena of refraction we also learned about that when the ray is traveling from denser to the rare medium, after refraction it bends away from the normal. It bends away from the normal. Therefore, continuously angle of incidence and angle of refraction continuously increases. Continuously increases. When the ray comes very close to the ground, the angle of incidence is slightly greater than the critical angle of a medium. And due to that reason, finally, this ray undergoes the total internal reflection and enters the eye of an observer. Again, a ray is coming from the top of a tree, that means the deep one. This tree is at far distance. So this ray is traveling from denser to the rare medium. That means it traveling continuously from the medium which effective index is continuously decreases. Therefore, the angle of incidence and angle of refraction are continuously increases. When the ray approaches to the ground, so the angle of incidence is much greater than the critical angle. Therefore, finally, it undergoes the total internal reflection and enters the eye of a person or the observer. So, person or the observer feels that the image of the tree is shown at the DS point. Is that DS point? And this effect is known as the Diaz effect. Clear this? So there is the two applications of the total internal reflection. Now the next application we are going to discuss. Okay. Okay, now third application of optical fiber is in right angle prism. So how the total internal reflection phenomena is used in right angle prism. Generally, we are using the prism of the glass for the dispersion of light. But in industry, the prism are used to divert or to make the change in the direction of incident light by 80 and 90 degree or 180 degree. Therefore, the prism are designed to bend a light by 90 degree or 180 degree, making the use of total internal reflection. Again, the main purpose of the right angle prism is that to bend or to divert the light by angle 90 degree or 180 degree by using the concept of the total internal reflection. Now, the prism is in form of a right angle triangle shape. Therefore, this angle is 90, remaining 2 are 45, 45. Suppose we want to turn this incident light by 90 degree. At the time, keep the prism this way. when the light is incident on this, so this surface is inclined surface at 45-degree angle. Therefore, this incident light, now there is the point of incidence is due to the global on this point of incidence, so this angle is 90 degree. So there is also again 45. So here the phenomena of reflection take place. So this angle is of 45. So there is the incident at 45, reflected also 45 angle for this ray and also this ray. Now, this angle of incidence is 45, that is the greater than the critical angle of the prism and A interface. Generally, the prism are made from the glass. The glass is the refractive index is 1.5. The glass has the refractive index is 1.5. Corresponding to this refractive index, what is the critical angle for A glass interference? So we have the equation sin IC is equal to 1 upon n, or the n is equal to 1 upon sin IC. Therefore, sin IC or the sin C is equal to 1 upon n. Therefore, C is equal to sin inverse 1 upon n. We substitute the n is equal to 1.5. Therefore, we obtain the angle is approximate 42 degree. This 42 degree is the critical angle for the glass A interface. But here, the light incident at 45 degree angle, there is the more than the critical angle. Thus, this incident ray undergoes the total internal reflection. So this way, we can divert this incident light by 90 degree angle using the light angle prism. Now, thus the critical angle is less than the 45 degree for material of a prism. Therefore, whatever the light is incident at more than 42 angle undergoes the total internal reflection. Thus, the prism are used to invert the image without changing its size. Here, the prism is used to invert the image of this object without changing its size. Here, the size of AB is the object. Here, the same image having the same size of AB is obtained, that is the B dash, A dash, or A dash, B dash. Clear this? Okay. Here there is a discussion for as we want to convert the image or we change or we bend the incident light by the 90 degree angle. Suppose we want to make the bend by 180 degree, or we want to obtain the inverted image by 180 degree. At the time, what is the figure? Figure is this. There is again the prism is this. There is the ABC prism. ABC prism. Here there is a 45, and also there is also 45 degree angle. Okay. So it's 66. Okay, now listen. Here the light incident. There is the incident here. As we do the normal at these 2 points. So here again, the angle of incidence is this. So this angle of incidence is much greater than 42 degree. Therefore, this incident light undergoes the total internal reflection. Right? Therefore, this light is total internal reflection and incident on the BC surface of the prism. Again, it suffers the total internal reflection, and finally, this light is reflected in this direction. Therefore, incident light is in this direction. Final or the emergent light is in opposite direction of this. Therefore, 180 degree bend of incident light take place, and our image AB is now obtained as A dash, B dash, that is the 180 degree inverted. So there is the application of the right angle prism by using the concept of the total internal reflection. Okay, clear this thing? Okay. Now the last and fourth application of the total internal reflection is in fiber optics. At present, in these days, in communication system, we are using the fiber optics for mobile communication and also the digital communication. And also in medical sciences, the fiber optics are also used. We discussed in the case of the uses what are the applications of the fiber optics. Now, there is also possibility of this question answer for the 2 marks. Explain the principle, construction, working and use of the optical fiber. What is the principle? The principle of the optical fiber is the total internal reflection. So it's therefore the optical fiber works on principle of total internal reflection. Now, what is how the fiber optics or the optical fibers are prepared? Generally, these optical fibers are prepared from the high quality composite glass material or the pure quartz material. Optical fibers are made from high quality composite glass or the quartz material. Each fiber consists of core and cladding. Here there is the very thin, its diameter is approximately 100 micron. That is the very less compared to the head of our head. Okay, so here due to the very thin we can bend in any direction without breaking. Okay, here there is each fiber has the consists of the core. Core, that means the inner side, and cladding is outer cover of this core. So there is the cladding, there is the core. Core has the higher effective index compared to the cladding. That means what is the cover material has the less effective index compared to the inside material. Reason is that to prevent the leakage of the incident light or the light passing through the fiber optics. Okay. Now again, so optical fibers are made from the high quality composite glass or the quartz material. Each fiber consists of the core and cladding. The effective index of the core is higher than the effective index of cladding. How it works? Okay, there is a very thin cylinder, one type of. So when the signal of the light or the light is entered one end of the optical fiber at a certain angle or the certain angle with the fiber, so it undergoes the total internal reflection along the length of the fiber and comes out at the other end. Again, what's happened? When the signal of the light is directed or the entered at one end of the fiber at a suitable angle. So here the angle of incidence is this. There is the perpendicular angle of incidence is this. So for this angle, so it undergoes the total internal reflection and along the length of the fiber and comes out at the other end. Now, this light undergoes the total internal reflection at each stage. Here, this, again this, again this, again this. So what's happened? There is no loss of energy or the intensity of the incident light. Okay. Why this undergoes the total internal reflection? Because here the cladding has the less effective index compared to the core. Therefore, this light of there can't escape from the fiber, and also the loss of energy of this light ray is also prevented, or the leakage of the energy does not take place at the edge of the fiber due to the less effective index of the cladding material compared to the core. Okay. Now, optical fibers are fabricated such that they are reflected at one side. So what is the reflection take place at one side of inner surface? So strike the other surface. Here the reflection take place at one side of the surface, strike at the other side of the surface at an angle. Which angle is larger than the critical angle? Therefore, at each end of reflection, it undergoes the total internal reflection. Again, you understand that the optical fibers are prepared for the fabricated in such a way that the at one side of a surface, inner surface, the light is reflected. There is the strike on other side, or the other surface of the side. with an angle that is higher than or the larger than the critical angle. So as a result, it undergoes the total internal reflection. And due to that result, even if the optical fiber is in bend form or the bend, the light can easily pass traveling along its length. Thus, the optical fiber can be used to act as an optical pipes. Clear this? Actually here, the total internal reflection phenomena is used for the multi-reflection. And during this multi-reflection, here the loss of energy is very, very less. In 1 kilometer, only 5% energy or the intensity of the light is lost. Okay, so that is the principal construction and writing of the fiber optics. Now we discuss about what are the uses. Generally, the use of the fiber optics is the transmit and receive the audio and video signal. Audio and video signal are in electrical pulses form. So with help of the transducer, so that is converted into the electrical signal, the light signal, and this light signal are transmitted and received by the optical fiber. That means the very large application of the fiber optics is in communication system and also the medical sciences. Okay, we will start the discussion about the uses of fiber optics. Now, uses of optical fibers. Now, optical fibers are used for transmitting and receiving the electrical signal. In communication system, here directly the sound, audio, or the video file are not directly transmitted because it not travel a long distance. So first it convert into the electrical pulses or the electrical signal. This electrical signal are also weak, are not able to transmit or receive. Therefore, we have to convert this electrical signal into the light waves. For that purpose, one device is used, simple device. This device is known as the transducer. And the device is convert the one form of energy, here the electric form of energy into the light energy. So energy into the other form of energy, that is known as the transducer. So with help of a transducer, we can convert the electrical signal into the light signal, and then this light signal is passing to the optical fiber, and due to the total internal reflection, it can easily travel for the long distance. At the other end, whatever the light signal is obtained, the loss in intensity is very, very less. And due to that result, at present, we are using mobile communication, the clarity and speed. So with help of an optical fiber. And at present, the numbers of the signal we can send in a one optical fiber. And due to that reason, the speed takes place. Okay, now, it is also used for the medical sciences. It can be used for the transmission of optical signal. These are used as a light pipe to facilitate the visual examination of the internal organs. Now, what are the organs in our body? So, how we can examine for the visually see. In medical science, for that purpose, the fiber optics are entered in our body with the camera, and we can examine or the visually check our internal organs. So, that is the application of fiber optics. And also in decoration, in decorative lamp, here the fiber optics are also used. In decorative lamp, here generally this type, there is the lamp, here the holder and the lamp is given. Here the fiber optics are inserted this way like the fountain. One end of the fiber optics is in contact or very close to the glass, while the other end are free. When the bulb is switched on, so light is passing to the fiber optics, and at the end or the free end of a fiber optics, the black spot is shown. So that is the decorative lamp for the application of the fiber optics in decorative. Clear this? Okay. There is a very easy, only keep in mind the construction, principle and working and also the uses of fiber optics. Okay.